what exactly is the scale representing here in this video? You must be seeing the title by now. It says number line, right? Is this not a number line or a representation of a number line? Pop this question in your head. It is a small scale. It has one end. However, numbers doesn't have an end. It has an end, two ends, and there's one straight line drawn and equally divided into 15 parts, right? So that means starting from 0 to 15. These are not whole numbers. These are not represented on a scale. That means these are not represented on a number line. Let's find out. So as you have guessed right from the title, today's video is about number line, how to represent whole numbers on number line and how to perform operations using number line. Along with that, we'll see predecessor and successor of a number, how to find them using number line and also without number line using the concept of number line. Now let's see. As I've told you, number line is a straight line which is similar to that of a scale. Now let's try to draw a number line. So I'm drawing this number line here. Okay. I'll start this number line from 0. Remember, you can also represent negative numbers on the number line. However, this topic is all about whole numbers, and we can also, because all natural numbers are whole numbers, will represent them together in the number line. So I am using 0 as my starting point of the number line as we have seen on the scale. 1, 2, 3, 4, 5, 6, 7 and 8. So this number line could accommodate 8 numbers. A number line can be infinitely big, but it is practically not possible to represent all the numbers on the number line. So if you have a range of numbers, for example, if you want to represent even numbers and then show that the difference between two numbers is 2 spaces, as in spaces this and this, then you can represent a number line only for even numbers. So based on the purpose, we will use the number line accordingly. Now here I have represented numbers on the number line from 0 to 8. Now what is the distance on this line from 0 to 1? On this scale, again to our scale, 0 and 1, I've told you that there are 15 numbers on the scale which are equidistant, that is of equal distance, right? And one number, that is this much length, is 1 centimeters. So this short scale is of length 15 centimeters. So now here, rather than using centimeters, we'll use unit because we are not doing it on a scale, right? So this is 1 unit. So in between two numbers, we have 1 unit distance. Same thing with 1 and 2, 1 unit distance. And then 2 and 3, 1 unit distance. So this goes on from 0 to how much ever long line you need. And the distance between two numbers is 1 unit. Here 1 unit is nothing but, do you think it's plus 1? That is 0 plus 1 is equal to 1? Yeah. And again, do you think this is again plus 1? 1 plus 1 is equal to 2? Yeah. And 2 plus 1 is equal to 3? Can you see the pattern here? That means all the numbers that are right of 0 here are greater than 0. Do you agree or not? So, if I say the leftmost number is 0, I am adding 1 to it. It is 1. And is 1 greater than 0? Yes, it is. Now, I am adding 3 to this, it is 0 here. So I'll say this is one distance, one distance, one distance. So that means the distance from 0 to 3 is 3 units, and 3 is greater than 0 because it is towards the right. And you know that if we start a number and if we go right of that number, it is nothing but we are adding 3 units in this case. So that means all the numbers that are on the right side of the number line are greater than that number. Okay, so here all the numbers that are towards the right of 0 are greater than 0, and it is true. 8 is greater than 0, 7 is greater than 0, right? Now let's see another scenario, that is the opposite scenario. Now we are starting from 8 here. This is towards the right corner, and I want to go back to 7. How do I do that? What will give you 7 from 8? You will subtract 1 to get 8. See the direction here, and you are coming towards the left hand side on the number line. That is 8 minus 1 is equal to 7. And then 7 minus 1 is equal to 6. 6 minus 1 is equal to 5. See the pattern here and see the pattern here. That means any number that is to the left of a chosen number is on the number line is always less than that number. Here it is greater because it's on the right, and here it is less because it's on the left. 8 minus 7 is equal to 1. So the distance is 1. And 8 minus 1 is equal to 7. Am I right? So this is where the basic operation of numbers have come into picture here. Addition, subtraction, multiplication, etc. So you must be having a doubt. Why can't we add, subtract, multiply using this number line? It is not possible. It is possible, but it's practically not possible. If I ask you an addition of 5620 plus 75, 75 is where and 5620 is where? Its range is so long that you can't represent them in the form of number line. That's why we choose to add them together using our own operation method. Just adding two numbers using plus sign. Right? But number line is the basis for all the operations. Okay, that is something which you need to know for sure. Now, this basic number line is this. That is, all the numbers towards the right of a chosen number are greater than that number. All the numbers towards the left of the chosen numbers are less than that number. Now, I'll try to perform simple operations using this 0 to 8 number line. Just to let you know how exactly we do operations on number line. And then we'll jump on to the properties of whole numbers and how to represent them in the form of number line. Now, let me draw another new fresh number line here. Okay. Please ignore if it's not straight. 1, 2, 3, 4, 5, 6, 7. I wanted to do 8. So I can perform operations. Now, how do you do addition on a number line? Right? Suppose remember the concepts that I have taught you in the previous just 2 minutes before, that all the numbers that are right side of a particular number will be added and they are greater, and all the numbers that are left side of a particular number are subtracted, that is less than. Right? Now, I want to add 0 and 2. And remember, every number is 1 unit distant. Right? So, how do I add 0 and 2? That means here 2 is nothing but just 2 units from 0. So, take the smallest number here and then add to it. that is 1 and 2. So you'll get answer is 2 here. That is how you add. Okay, now let's take a bit more big number in terms of this number line. 3 plus 4. How do you do 3 plus 4? What is the smallest number? 3. Take the smallest number and go on adding 4 times. That is 4 different units. Plus 1, plus 1, plus 1, plus 1. So here, where did we land at? 7. So we landed at 7. That means 3 plus 4 is nothing but 7. This is where all your operations started. Number line will give you more in-depth analysis on how these operations came into picture. Now let's try to do subtraction. You know that anything that goes to the right is addition and anything that comes from the left is subtraction. Right? Now how do you subtract using a number line? For example, 8 minus 6. Right? Start from 8 and come back 6 times. It is minus 1, minus 1, minus 1, minus 1, minus 1, minus 1. We landed at 2. So 8 minus 6 is 2. That's how you subtract. Let's take another number. 6 minus 3. Okay. Subtract 3 times. Where did we land at? 3, because 1, 2, 3, we are coming back. So 6 minus 3 is 3. That's how you subtract using a number to multiplication. Now, I want to multiply 2 into 4. Okay. So multiplication, how do you do is, you divide the entire number line into 4 different units that consists of 2 units each. That is, here it should be equidistant, but instead of 1, it needs to be divided into 2 parts. That's where we'll get our multiplication. Now let's see how this is achieved. I said 2 into 4. I'll do from here. I told you we need to equidistantly divide. 2. This is 1, 2. This is 2, 2. This is 3, 2. And this is 4, 2. So, how much did you get 2 into 4 as? Where did you land finally? 8. So, this is how you do multiplication. Take the entire number line, find the smallest number, divide that into the largest parts and then add. Multiplication and addition are always codependent on each other, right? So this is how you perform multiple operations on number line. You must have been taught all these in your earlier classes, but I want to recap all these concepts to you so that you will know and you will take your way forward with other concepts that we will be dealing in the next few chapters. Now let's see the whole numbers. How is this number line associated to the whole numbers and what are the different properties that we get in terms of this number line? For example, what I'll do here is I'll just quickly ask you a question. What is the first number of this number line? 0. That means this entire number line is whole numbers. They all fall under whole numbers because it's starting with 0. And as I told you, even in the properties of whole numbers also, any number that is greater than 0 they will lie towards the right hand side of the number line. Right? 1, 2, 3, all these are greater than 0. So these numbers that are greater and that lies towards the right hand side of a number line are called successors. Okay, successors are nothing but greater than the number. It can be of any number. When I say what is the successor of 7, you should say 8. Successor is immediately next to that number. That is immediately. That is 1 greater. Plus 1 is successor. Okay. Now, so we have greater. So we must be having something that represents lesser also. What is that lesser then? Is nothing but predecessor. That is previous number. Immediately previous number. Minus 1 number. Let's put these concepts in use on the number line. Okay, I'll ask you a quick question. 3. What is the successor of 3? 4. Correct? Because it's plus 1 immediately next. Then what is the predecessor of 3? 2. Immediately towards its left. Right? In the same way, any number on the number line or any number in general on the number systems, if we have a number and if you want to find out the successor or predecessor of a number, you will add and subtract by 1 respectively. Okay. We will apply this concept into the larger numbers also, but for now, this is one of the rules that you need to remember. There is one catch here, and the one basic question that everyone would ask me is there a predecessor for 0? In whole numbers. Remember, in whole numbers. No. In whole numbers, we don't have a predecessor for 0. In normal real numbers or normal number system without whole numbers differentiation, in general we have minus 1, negative integer that just comes before 0. But negative numbers are not a part of whole numbers, right? So whole numbers start from 0. So there is no predecessor for 0. Okay, so this is one of the concepts that you need to keep in mind while writing whole numbers. In the same way, we can derive predecessor and successor for larger numbers also. Let's see how to do that very quickly. 2, 5, 6, 7, 8. I want to find the predecessor and successor for this number. Don't get intimidated. It's a big number. The concept is same. So, remember, predecessor means previous. Successor means next, immediately previous. What is the predecessor of this number? You know that predecessor we need to subtract by 1. So that is 2, 5, 6, 7, 7. What is the successor of this number? Take this number and add by 1. That is 2, 5, 6, 7, 9. So this is the predecessor. And this is the successor. Another number. Okay. I'll give you a nice number. 99,99,999. If you remember my first video, the introduction to numbers, large numbers, I've told you that if we add 1 to the 7-digit largest number, we'll get the smallest 8-digit number, right? Same concept here. In order to find the successor, you'll add 1 to this, and immediate successor to this is smallest 8-digit number, that is 1 crore. So, right? 7-digit number, we get smallest 8-digit number. Now what is the predecessor? We need to do subtraction. We will get 99,99,998. This is the successor and this is the predecessor. In this way, we can find successor and predecessor for many problems. Any digit. As you can see on the board, the successor of a whole number is the number obtained by adding 1 to it. And the predecessor of a whole number is 1 less than the given number. Okay, so this is what I was trying to summarize in the previous video. Now let's try to apply this concepts on a few numbers. Here I have written 10,000, 40,999 and 1 million. So let's try to find out the predecessor and successor of this. What is the predecessor of 10,000? It is 10,000 minus 1, that is 9,999, right? And the successor is 10,000 plus 1, that is 10001. Okay, now let's see what is the predecessor and successor of 40,999. That is 40,999 plus 1, that is 41,000, right? This is a successor, sorry, not predecessor. Now what is the predecessor? It is nothing but you need to subtract this, that is 40,999 minus 1, that is 40,998, right? This is the predecessor. Now let's try to find the predecessor and successor of 1 million. Now 10,000 minus 1 is the predecessor, 10,000 plus 1 is the successor, right? So what is 10,000 minus 1? 10 lakhs minus 1, 10 lakhs plus 1. 9,99,999 is the predecessor and 10 lakhs 1 is the successor. So this is how you find out a predecessor and a successor of any number for that matter. And so I've dedicatedly explained you the concept of predecessor and successor and number line of whole numbers just for your information so that you'll understand from where we are coming to these concepts in future topics also. So I hope you really understood the concepts learned so far. So if you like my video, I request you to like, share and subscribe to my channel and ring the bell notification down below so that you will never miss an update for me. So after this, we'll be seeing properties of whole numbers. We'll start with a closure property, commutative property. In depth, I'll try to cover all the properties for you so that you will not forget these properties as and when we deal with the next system of numbers, that is rational numbers, real numbers, etc. Because these properties remain the same. This logic, the reason behind these properties is still the same, just the numbers will change. Okay, so till then I hope you stay safe, stay happy and enjoy the rest of the week. Now you'll be seeing the puzzle of the day and followed by the solution of the previous puzzle.